So in this video, what we're going to do is solve an equation that is in quadratic form, but we're going to work with an equation that has nice whole number exponents. So we start with our equation. We have a fourth degree polynomial, x to the fourth minus 37x squared plus 36 is equal to 0. And then we want to recognize that the x to the fourth can be rewritten as x squared squared. 2 times 2 is 4, so one exponent being raised to another, we multiply exponents. So it's the same expression written differently. Minus 37x squared plus 36 equals 0. And then what I want to do is recognize that if I make the substitution, let u equal x squared, everywhere I see an x squared, if I replace it with a u, so here I get u squared minus 37, replace the x squared with u, plus 36 equals 0. Now I have an equation that looks like a quadratic equation. So I have an equation here, the original, that is in quadratic form, because using a substitution, u, for an algebraic expression, I can reduce it to a form that looks like a quadratic equation. Now I can solve this using quadratic equation techniques. I can complete the square, I can use the quadratic formula, I can try to factor it and use the zero product property. Any of those techniques that were appropriate for solving quadratic equations are now appropriate to try to employ on this equation here. In this case, this factors pretty easily as u minus 36 times u minus 1. We have negative 36 times negative 1 is positive 36. Negative 36u minus 1 times u is minus 37u, and u times u is u squared. So we can do multiplication to verify that the factorization is correct. And then from here, because we have a product of two algebraic expressions equaling 0, we can use the zero product property to say either u minus 36 is 0 or u minus 1 is equal to 0. And then what we need to remember is that u is actually x squared, so I can do a substitution. If u minus 36 equals 0, replace u with x squared. That means x squared minus 36 needs to equal 0, or x squared minus 1 needs to equal 0. And then what I want to recognize here is that the linear term, the x term, is missing. It's a 0x, which means that the easiest way to solve this is going to be to get the 36 over on the other side. So we use the square root property. So x squared equals 36 by adding 36 to both sides. And then we take the square root of both sides to cancel the squaring. But we need to remember when we take the square root of 36 to do plus or minus the square root of 36. The square root of 36 is positive 6, so we get x equals plus or minus 6. And over here, again, that linear term is missing. So the square root property is going to be the easiest to use. So we get x squared equals 1 by adding 1 to both sides, and then take the square root of both sides. But we need a plus or minus the square root, which equals plus or minus 1. So the solution set is going to be x is an element of the set that contains plus or minus 1 or plus or minus 6. And you could, if you wanted to, plug those back into the equation and check that they actually satisfy the equation, that they zero the equation out.